Welcome to my video classes. Today's topic is force on a current carrying conductor kept in a magnetic field. We all know force is a vector quantity. So it has both magnitude and direction. The magnitude of the force acting on a current carrying conductor placed in the magnetic field is given by F equal to BIL sin theta. So where B is the strength of the magnetic field, I is the current through the conductor, L the length of the conductor, theta is the angle between the conductor and the magnetic field. Now, depending on this angle theta, the force takes the minimum value to the maximum value. We get the minimum force when the theta is 0 degree. It means the conductor is placed parallel to the magnetic field. Okay, so when the conductor is placed parallel to the magnetic field, then there is no force on the conductor. Whereas when the same conductor is kept 90 degree with the magnetic field, perpendicular to the magnetic field, then we get a maximum force. Okay, so in that situation we can directly use BIL because the sin 90 value is 1. Okay, other than this 0 and 90 degree, so it means in between values we get for the force. Okay, now focus on the direction of the force, which is very interesting. So the direction of the force on a current carrying conductor placed in the magnetic field is simply given by the right hand rule. Okay, we have to open our palm and we have to place our palm in such a way that our fingers should point towards the magnetic field. The thumb should point towards the current. Then from the center of the palm, okay, out of the palm, in this way the force acts. Okay, so like this. Now depending on the situation, we have to keep rotating our palm, okay, such that the fingers magnetic field direction, the thumb the current direction, then from the palm outwards this is the direction of the force. Okay, like this also. In this case, in the second picture, this is the direction of the magnetic field B, and here this side is the thumb points towards the current direction. Okay, so from the center of the palm upward, this is the force direction. Okay, depends on the situation, we have to keep adjust. Okay, like this. Okay, the fingers always points the magnetic field. Okay, the thumb always points towards the current. Okay, whereas from the center of the palm outwards, this is the direction of the force. Okay, now like this. Now let's do a simple experiment, okay, which shows from that we will find the direction of the magnetic force, okay, acting on a current carrying conductor. Today we are going to see the force acting on a current carrying conductor kept in a magnetic field. So here we can see this is a conductor and this conductor is kept in the magnetic field. So this is the north, this is the south. So the magnetic field direction is from north to south. It means, okay, downwards. Now, so one end of the conductor is connected to the negative, the other end is connected to this end is connected to the positive of the battery. Okay, now let's switch on. Observe what happens. Yes, it is deflecting this way. Let's see. So in this case, this is the positive, so the current is moving this way, so the thumb should be this way, and the magnetic field is, this is north and this is south, so this is downward. So this way we have to keep our right hand rule to find the deflection direction of the force. Now, so we know that always from the palm outwards, this is the direction of the force. That is the reason, okay, it is deflecting this way outwards. Let's see what happens if we change the direction of the current. Plus minus are interchanged. So in this case, okay, so this is the current, so the current direction is now this way, so the finger is this way. Now the magnetic field, we did not change any direction of the magnetic field, it will be down only. Now the deflection will be, we can observe the deflection this way, left side. Okay, let's check the same. Switch on. Yes, easy. So a current carrying conductor kept in a magnetic field, it experiences a force, and the direction of the force we can obtain by the right hand palm rule. Okay, the force is, so this, the fingers points towards the magnetic field, this is the direction of the current, and the force is from the palm out. Okay.